Hi, in this video I want to dig a little bit deeper into this idea of these interrogator functions and how we can interact with the data set in a very sort of relatively straightforward way. I think actually that's one of the really cool aspects of the mrTools of the mrLoadRed, that you can execute relatively complicated things and interrogate your data set by clicking on voxels, right? And so you can get out much more than just a time series. You can sort of do arbitrary model fitting and various explorations and make nice plots, which allows you to look around some data sets, especially if it's something slightly more unusual, like often was the case with 70 data sets, or when you have very high spatial resolution, or when you're trying out something slightly unusual. Okay, so I am once again in the folder that we started setting up with this demo data set. So I'm just going to start mrLoadRed in this folder. I'm going to pop up what we've loaded before because of this mrLast view variable that keeps track of the state of the GUI window. And as I showed in one of the previous windows, under the plots entry in the menu bar, there's this option for interrogating overlay, which you can switch on. Okay, so just before I do that, just note down here in the bottom left, there's sort of some clear real estate in the GUI. If I switch interrogate overlay on, this gets populated by this pull down menu and a text field here. And when you first do this, you may not actually get a function in here, but for the time series statistics, there's a default interrogator function that gets put in here, which is called either time series stats plot, or sometimes you might see time course plot as well. Okay, so I'm going to switch to time course plot here. You can also type the name of any function that is on the MATLAB path in here. And I will explain to you in a minute what some of the requirements are. At this point, if you're typing the name of a function in here, so let me just zoom in here, it says time course plot, and if I hit return, it will be accepted, right? So the GUI accepts this. If I accidentally mistype, then there's some checking going on, and you see that it corrects to one of the previous entries, because you don't want to have a function in there that's not available to MATLAB, because this can cause errors when you try and do the next step. So with this time course plot function there, I now go to the GUI window, and you can see that the data window which we're looking at, the cursor has actually changed to a crosshair, and there's some coordinates just underneath that give you some information about where you are on X, Y, and Z in scan space, in the base space, and magnet space. We'll do much more about alignment in one of the future videos, later on in the series. For now, we're just considering the data in the space in which they were acquired, so these different numbers don't really make any sense yet. But when we start aligning things to a common anatomical image or into a template brain, then those things are going to change slightly. So if I go to one of the voxels here and I click on it, what happens is a function with the name time course plot gets executed, and the GUI hands over a small amount, but crucial amount of information to this function in order for it to do its job. And in particular, it needs to know where did you click, where on X, Y were you in the image, and what slice were you on, what was the current analysis that was loaded, did you click inside a region of interest or not, and so on and so forth. Okay, so we can have a look at this function. So it's called time course plot. So if I say help time course plot, you get some very minimal help. Where is it located? It's part of the standard mrLoadRed install. It's one of the plotting functions that's there. If we want to look at it, you'll see that it's not a huge amount of code, and I will unpack some of these things in a little while. The thing I want to point out to you here is that this function has a very particular interface. So it expects a certain number of input arguments in exactly the right order in order to fulfill its contract, so to speak, to become a proper interrogator function. Okay. So what this means is, if you write any function that has this particular interface, it accepts a view, then an overlay number, then a scan, then an x, y, and z number for the coordinates and a region of interest, then the function you write can be an interrogator function. So to help make this a bit more clear, I have actually, I provide you in the GitHub repository sort of a blank version of this interrogator function that doesn't really do anything. So it pops up a window, but it doesn't do anything. Now, because this is not on the MATLAB path at the moment, in order for this next step to work, I'm going to switch back to the window here. Let me just make some space, real space on the screen. And I'm going to add to the path the folder where I keep the tools, actually the GitHub repository with the code that I've included. Okay, so for me that's MATLAB intro to mrTools. For you it will be wherever you have cloned the GitHub repository to, where you've stored this function called blank interrogator. Okay, so if I now type which blank interrogator, you'll see the path to this. If this doesn't work for you, then that means you've either added the wrong folder to the path, or there's something else wrong with where you've stored this particular file. So this means MATLAB now knows about this blank function here, blank interrogator function. And in theory, if I go here and I type in blank interrogator, then MATLAB should accept this. Okay. So if I click outside, it hasn't changed it back to anything else, which means it's an acceptable name. So it's on the MATLAB path for now. And when I try and click the button somewhere in the window here, we'll run the code that's in this function, blank interrogator. Okay, so let's have a look at this here. So it was actually, I've taken this time course plot function. I've added some additional comments here for you to understand a little bit about what's going on. The other thing I've done is I've changed the first input argument, which is called view in the other function, to a v. So that means when we're talking about the code on the inside here, we need to actually refer to the view as v, not as view. That's in order to avoid the clash with the MATLAB function view. Well, that's a bit of a detail. And so let me just walk you through the first few lines of the code here. Okay? So the first bit here is we're checking whether we're getting any number of arguments between 1 and 7. And if not, print out the help for this particular function and return. But because we're going to use this function from within the GUI, as I noted in the comments, the arguments will be provided by the function, all right? Because we are running this function not directly from the command line, but by clicking a button and sending the information from here, we're essentially guaranteed that we're sending all of the information to this particular function when it gets run. The next thing is there's a function that selects the graph window rather than the mrTools window. That means when we're putting a plot, we're not starting to plot into this window here, but in the separate graph window. We find out what the figure number is. We change some of the properties, so we remove the number of the figure and give it a name. And so what I expect to happen, if I did this correctly now, is when I click on a function here, I should get a window that has a title blank interrogator, but doesn't contain anything. Okay, so I'm just going to click on the function here, and sure enough, that's what we get. Blank interrogator, nothing plotted in here. Okay. I can do an additional bit of debugging here, or finding out what's going on. I can maybe display, so I'm going to say display some of the input arguments. Okay. And so I might, for example, display, actually, let me use fprintf. So that makes it, if you send to file ID 1, that means to the standard out. So it will come out in the command window. User clicked at, I'm going to say, these are format strings. So 3 integers. And the integers I want to print are x, y, and s. Okay, actually, I want to also put a new line here. I'm going to say x, y, s. So what does this mean? When the user clicks this interrogator function in the window, x, y, and s will be passed into this function depending on where you click in the window. This new window gets set up, and for now, in the command line, we should see user clicked at and 3 numbers and a new line, if I've done this correctly. Okay, so we should see this text appear over here when I do this in the window. So let me just do that. And you can see it pops up the window, and it also said we clicked at 46, 28, and 10. All right. So the next thing I might want to do is actually display something in the graph window. And for now, let's just put a figure window, right? So I'm just going to plot something, and I'm just going to plot just some random numbers actually to get 100,1, right? So just to show that we can also send things to the graph window instead of the command line. I'm going to press the save button, switch back here. Now I get a plot of random numbers. Okay, but obviously that's not a very useful function if just every time we click on a overlay point we get a random function. What we'd really want to do instead of plotting a random number is we would like to do something more useful, like for example, plot the time course from the location where we clicked. Okay, so how could we go about doing that? So it's worth thinking for a second about what we're actually looking at here, right? So in this window here, we are looking at data from this group called motion comp, scan number 1 at a particular slice. We've already seen that when we click on here, this window takes care of the actual finding the coordinate at which we clicked. Okay, so we don't have to worry about the slice number. That information gets passed on, but the time series data is not available. We need to actually load this in a separate step. Okay, so there's a whole bunch of functions that allow you to load analysis in and so on, that if they're not already in your data view. For loading time series, there's a special function called load T series. I'm just going to get some help from that. We provide it with a view, a scan, slice, frame, x, y, and various bits of information. Loads time series corresponding to the specified scan and slice. Time series file must be in the appropriate thing, that's fine. Right, so frame actually refers to which time point we want, but actually we want all time points, so we want an empty bracket there. And so the question is, how can we provide all of this information inside this interrogator function? Well, the view we have, because it gets passed into the function, the scan we have, the scan number, the slice number we have, the frames we already said we want all of them, and XY we have as well. Okay, so let me just grab this function interface from here. I'm just going to grab this line from the help. And I'm going to copy this into here so we can see what's expected. And I'm going to use exactly the same logic here. So I'm going to say time series is going to be load t series. The view variable is not called view, but in our case it's called v because we decided to make this small change. So that's going to be v. The scan is called scan in our case. The slice is s. Frames, we want all of them. So if you go back to the documentation, you will see that we need to provide an empty parenthesis, and then there's x and y. Right? So there's also an option for precision and which group number and so on, but by default, the appropriate ones will be taken if you're launching from the GUI window. So I'm going to actually use the plot command to now plot these time series. And maybe I will plot it in black. I will say line width is equal to 2, and to make it look a little bit prettier. And on the x-axis, we're going to say time in volumes, right? Because we don't actually know what the seconds are. Appropriate time in seconds, something we'd have to figure out. And then on the y-axis will be MR signal, and for now we assume it's in units of image intensity. All right, so let me save that, and let's see whether this actually works. So if I press the button here, I've made an error. Time series cannot have more than 2 dimensions. All right, so I'm going to use this following db stop if error, which will send us into the debugger. And let's find out what's going on here. All right, so at this point, I can inspect the space here. It is a 4-dimensional data set. Okay, so T series, size T series. All right. So for those of you who've worked with multi-dimensional arrays before, you will recognize what this is. So we have we have an actual vector here, but it happens to be in a slightly weird shape for MATLAB in that it has these singleton dimensions where x, y, and z still exist, and because they're not trailing singleton dimensions, MATLAB considers this to be a 4-dimensional object, even though it's just a vector. If we use squeeze of t-series, which gets rid of the singleton dimensions, we get one thing that the plot will actually accept. Okay, so in this case, I'm actually going to make sure we squeeze this as well. Okay, so there's a little gotcha here. So worth keeping in mind. So let me press the button here, and now I do actually get the plot with the appropriate labels here. Okay. We can just plot somewhere in a place where I think it's going to be more interesting. So if we go to the ventral part of the cortex, maybe somewhere around here, this is where some of the fusiform and surface selective and object selective areas are, because of the experiment that was performed to get this data set, and there's some sort of more interesting looking shapes here. Okay. I will introduce much more about the actual design of the experiment in a video, but up to now we're just talking about the data set in sort of slightly more abstract terms, but we'll talk much more about what the fMRI experiment actually was, and how we can find out more about how to do sort of statistical analysis on these data sets. So I'll stop here with the interrogator functions. We can obviously become much more sophisticated about what we're doing in these interrogator functions, and I invite you to look at some of the other ones that are available. And in a future video, we'll also augment some of the stuff that's going on in here once we're ready to add some more mathematical modeling, or model fitting into the mix here. But I'll stop the video here, and in the next video we'll see whether we can achieve some of the loading of data sets and getting the same kind of information that we got by clicking on a particular location in a purely scripting kind of way without actually opening up a window and clicking buttons, which is a very powerful way of making your code reproducible and run across multiple data sets that were acquired under similar conditions.